Alright, we're going to talk about some more linear equations and just comparing properties of linear functions, give an algebra and a description. So we're going to have some algebraic equations and just a description of what's happening. So we've got two plumbing companies. We've got Daniels Plumbing and Kim's Plumbing. They have different ways of charging their customers. Daniels looks to be DT is $35 an hour. Represents the total amount of dollars that Dan's Plumbing charges for T hours of work. That's so cheap compared to what plumbing usually costs. Kim's Plumbing charges $35 an hour plus a 40. So just to show up, right? 35 plus a $40 fee to show up, right? Define the function K of T, Kim's Plumbing, and the amount of Kim's Plumbing charges an hour. Alright, so we'll write it up here. K of T not only charges $35 an hour, but K of T charges a flat rate of 40. So if I plug in a 0 here, right? If I plug in a 0, 35 times 0 is 0. Alright. If I plug in a 1 times 35 is 35. If I plug in a 2 times 35 is 70. And this just goes up by 35 every time to 105. For the ordered pair 0, 0, 135, and 270, right? Just $35, 3, another $35 is 105. This person, if I plug in a 0, that's 35t plus 40. That's what I should have put. It didn't fit in very well. Well, this person still has, right, 40. If I plug in 1, well, it's 30 plus 35 plus is 40, so it's 75. And then 110 if I add another 35, and then 145 if I add another 35. And so we get some ordered pairs that are always 40 more, right? They're always 40 more than this other one. 175, right? That's 40 more than 35. 2, and then we got 110, which is 40 more than 70. Then we got 3 and 145. 145 is 40 more than that. So domain and ranges are reasonable. Well, my domain, alright, my domain, alright, x has to be greater than or equal to 0, but probably doesn't go more than 40 hours a week, right? For both of those, alright? And the range would be if we plug those values in, right? So my range would be, let's say range, right? Would be from, well, 0 to, let's see if I plug in 40. What's 40 times 35 here? I'm going to find my calculator or not. Oh, I've got it. Not that it's too hard to do 40 times 35. It's about 1,040. 1,400, and that would be for the D of T. And honestly, the range for the other one would be from 40, right, to about, we'll say Y, right, 1,440, a little bit higher. All right. Let's look on this other side. We're going to graph them both. Graph the two functions. So this first one was 0, and then it went to 40, and then it went to 80, or it went up by 35s, huh? So then when it didn't go to 40, it went to 35, right about there, and then about 75, which would be right about there, and then let's go up to one we know. We know that 4 was 140. That's right on, and I'm going to get a little bit like that, right, with a slope of 40. Up 40 over 1, up 40 over 1, up 40 over 1, so on. This one's going to do the same thing, but it's going to start on 40. And I know that 4 gave me 180, so I'm going to go up to 180 with 40 and show that slope as well. How are they alike? Well, we've answered questions. They have the same slope. How are they different? Well, different. We could say y-intercepts, or we could say different starts. What information can be found about the two functions without changing their representation? We could find the slope. We can find, which is rate of change, right? Rate of change. There's the first. I'll be back soon.